Yeah, the previous class it was a demo that we did where we had ASBR, ABR, internal routers, and we were able to ping from one area to the remote area via area 0. And I showed you different Lsa types by typing show IP OSPF database command. Show IP OSPF database. We saw after redistributing from RIP to OSPF and OSPF to RIP, when we redistribute from RIP to OSPF, we started seeing type 4 and type 5 LSAs. And before we move further, the next topic will be stub, in which we will be learning type 7. Type 6 is multicasting. There's nothing to learn. When you have multicasting, type 6 will be seen. So, before we go and learn type 7, we have to learn another topic called stub. But, I remember in this batch, in the weekdays batch, I skipped this particular topic. Let us finish this one. Only then we can complete this chapter. We have finished up to type 5 LSAs. We have gone through these things. We did the lab, and for this batch I have not explained this E1, E2, so I have to explain this page onwards, and then I want to come back to this virtual link, finish this virtual link. So these two we have to complete today. Now, when you check the routing table of OSPF routes that you see in the routing table, some routes you will see O, like this. Some routes will have O, IA. Some routes will have O, E1 or E2, sometime N1, N2 and all in tomorrow's syllabus. We have not covered, not so stub area. N1, N2. What are these things? See? O, OIA, OE1, OE2. O means we know OSPF. IA means inter area. Now, O means OSPF routes learned because of the type 1 and type 2 LSAs. Type 1 LSA is router LSA. Type 2 LSA is network LSA. So the routes that we learn from the type 1 and type 2 LSAs are called as OSPF intra-area routes. Intra means what? Within the area. So within the area, networks will be having only O. When you see O, it means this particular network 10.1.00, it is not from another area, it is from the local same area to which this router B belongs to. So the router B belongs to the same area where these two networks are coming from. Simple O. Intra. This router B has learned it because of type 1 and type 2 LSAs. Next, OIA. As the word says, I means inter, not intra. inter area. Between areas. Intra is within the area. Type 1 and type 2. Within area. Type 3. Summary LSA. Intra. Between areas. So when you learn other area routes, you learn via type 3. When an area receives other area routes, it receives as type 3. Those type 3 learned routes will be shown in the routing table as IA. So in this example here, router B has got two networks coming from another area, 172.31.2.0, 31.1.0. These two are from another area. So we got within the area routes, we got between the area routes. Next, the routes that are coming from ASBR, the routes that are coming from RIP, how it is coming from RIP or EIGRP? It comes because we redistributed. Those routes are called as external routes. And by default, those external routes will be seen as E2, not E1, E2. External routes. The routes that you learn because of type 5. This is because of type 3. No, the summary inter area IA is type 3. And these both are because of type 5. We know about type 4. Type 4 is simply the router ID of ASBR. Type 4 is not going to bring any route information. So you will not have an example for type 4 in a routing table. In a routing table, type 4 has got nothing to do. Type 4 is just to tell OSPF process that we have an ASBR in this location for external routes. So type 5 is an external route LSA. That's why it is given E. E means type 5. Learned. Router B has learned because there's a type 5 LSA bringing this route. Type 5 LSA. What about E1? We have E2. What about E1? Both are type 5 learned routes, but when you have E1, you will not have E2. When you have E2, you will not have E1. So what it means, E1 and E2? I said when you have E1, you will not have E2. For a destination, you cannot have both. What does it really mean, E2? E2 is default. Again, I'm repeating again. E2 is default. When the route is redistributed inside OSPF, all those redistributed networks will be seen as E2. What is the E2? You see, when this RIP routes, here in our example we had RIP, Routing Information Protocol, RIP. When we take the RIP route and redistribute into OSPF, the metric given is, for example, the metric given is 1785. If you don't give this number, any number, the default will be 20. When you redistribute RIP routes into OSPF, all those RIP destinations, all those RIP networks will have 20 as a metric by default. Whether it is 20 or some other number like what mentioned here, 1785, when it is E2, if you see, router 3 is learning this same number. Router 4 will also learn the same number. Router 5 will also learn the same number as a metric. But this is the metric on router 1, no? This is the metric on router 1. Why will the metric on router 2, 4 and 3 and 5 will be same? Why will it be same? Why is the metric same? When we have metric 10, 10, 10 in the path. It's supposed to be what? When it is 178, when it comes to router 3, the 10 should be added, no? But you see it is not added. This 10 and this 10 also should be added when it reaches 5, router 5. But you don't see them. It's the same metric that was given while redistributing is seen even after 3 routers. If you have 20 router, even in 20 router you will see same metric, which means the path metric is not added. That is what E2. E2 means path metric will not be added. But if you see E1, here it was 172.85 plus 10, 172.95 plus 10, 1805 plus 10, 1815. If all the path metric is added, then it is called E1, external type 1. What is default? E2. E2, the path cost won't be added. E1, the path cost gets added. So when you redistribute, if you will say, I want type 1, the command is metric type 1. Metric type 1. When you redistribute, if you mention this command metric type 1, then you will see path cost getting added. I'm going to show you this in some time. For the path cost to be added, we need to say metric type 1. If you don't mention it, it will be E2, where the path cost will be simply carried. Sorry, the path cost will not be added. The metric given while redistributing from RIP to OSPF will be carried inside without any change. Let's see this one first. So, good question, Sam. Question is, what is the reason to have E1? Why do we need E1? See, the default is E2. The reason why the default is E2 is mostly we will not be willing to calculate the path cost for the external network. The reason is they're external. They are going out. They are not, the external networks are not going to be within our office. External networks are via that one ASBR we have. Just one ASBR we have in our office, and our internal OSPF knows the shortest path to reach that ASBR. So using that, it will go and send the packet to this one. Type 4 LSA provides the location of ASBR. To reach that location, we already have the shortest path. So why unnecessarily we need to calculate the path separately for the external Yahoo network, Google network, Facebook, whatever it is? We have to come to R1. Wherever you may be from R5 or R4 or R, you have to come to R1. You already have the shortest path to reach R1 because it's OSPF network, OSPF router. So using which you will come quickly to R1 and deliver the packet here. And R1 will send it to external. So there's no need for calculating the route metric for the external routes by changing into E1. But in case if you have two internet connection, this is also another autonomous system. In our example, we have RIP on both sides. Or in real world scenario, you have two different ISPs connected. Two different ISPs. Now you see, if you have another area, area 2. Now this area 2 can reach this way to internet, may also take this way to internet. Which way it should take? According to me, I'll say it should take this way. For that, when I redistribute on this router, I'll say metric type E1, metric type E1. When I say metric type E1, what will happen? The path cost will be calculated. So for area 2, it comes here, one link 10 plus 10, 20. 20 is the E1. 20 is what going to be incremented to the original metric, 20. But if you see this way, 10, okay, 20 in this case. Let's say you have another router here, or let's say there is no link here. We don't have a link. So if you go this way, it is going to be now 10 plus 10, 20. Oh, again 20. Let's say you got another router. So 10 plus 10 plus 10, 30 this side. Wait a minute. I don't need this. I forgot to calculate this. So you see 10 plus, if you go this way, it is 10 plus 10 plus 10, 30. But if you go this way, it is 10 plus 10 plus, just that's all, 20. So when you put E1, all area 2 routes will go via this way. E1. Because E1 can differentiate and say this has got lower metric, then going to this ASBR is cheaper than going to this ASBR. Only when you put E1 it can differentiate like this. Otherwise for area 2 routes, for area 2 routers, both are same metric. When you redistribute, if you put the same number, both are going to have same metric. So in short, what I want to say is, for your question, only when you have more than one ASBR, only when we have more than one redistribution point, only when we have more than one router provides the same external routes, only when we have more than one router providing the type 5 LSA, we will configure metric type 1. Did I answer your question, sir?
Yes, sir, very well. Thank you.
Welcome. To understand the same problem, I have to rip here for E1, E2 problem. We'll come to that one later. Let us now, first of all, focus on the LSA types. We'll have a demo one more time with LSA types capturing and in a packet. We'll capture and see. As of now, we have only one ASBR, which is router 8, and we don't have this active. I have shut down here. I have shut down this port as well. Only one ASBR now. Let's check show IP route OSPF. Still the convergence has not happened. Let's wait. Meanwhile, I will also right click and sniff some packet here. Still have not seen any OSPF routes. It'll come in some time.
The profile you have put is UGRP.
It's okay, the profile doesn't matter. I can switch to OSPF profile after some time. Okay, see, I am learning from my own area that I update those updates. I can see it here, and I'm expecting more updates. Now more updates will come because 10:45. See, more updates have come, and then much more I'm expecting. I'm expecting E2. More updates are coming. You see behind the screen, you can see those things. E also has come. E2 has also come from router 9. I think I got all that I want to see. I'm seeing it already, so let me stop the Wireshark capture. Now let me go to OSPF profile. In this OSPF profile, we already did some colorings only for different message types, not for LSA types. That's why I want to create another profile. This is just to know how many DBDs have come, how many updates have come, how many updates, and so on. Okay, let's add with this same thing. Let's add. No need to create another profile. Let's add LSA types. I want to show you the LSA types. So LSA is nothing but an update advertisement, right? So this is the first LSA that I received. OSPF header version 2, link state update, message type 4. This is LSA. This is message type 4. This is not LSA type 4. Okay. This is not LSA type 4. This is LSA type. LSA number is 2. 2 is router LSA. Look at this. Router LSA. Type 1. Sorry. LSA type 1 is router LSA. There are 2 LSAs received. This is not type 2 LSA. There are 2 LSAs received from 10.34.0.3. One is router LSA. Router LSA is nothing but the LSA that brings the information of the local area. Router 4 is advertising. The link state ID is this. It is receiving from an ABR router. Check the topology. Yeah, router 4 is an ABR. We are sniffing between router 3 and 4. So router 4 from router 4 from router 4, which is an area border router. From router 4, that's the router ID of router 4, area border router. We are learning about 4.4.4.4 with the mask of this and the metric of this, and we are learning about 10.34 with the mask of this. See, this is the network, this is the subnet mask. About the stub network we'll learn later. Likewise, 10.34 is directly connected. And then in type 3 LSA, because it's an ASBR, because it's an ABR, it will also, okay, anyway, no update inside. This is an ABR, it can send type 3, but no advertisement inside. So let us now go to the next one. Next one, when we see this update is again type 1 and type 2. There is no type 3. This is only type 1 and type 2 advertisement. This is coming from where? From router 4. No, it's coming from router 3. How can router 4 send only type 1 and type 2? Earlier we saw ASBR, which is router 4, ABR. Now it's coming from an internal router. Internal router can send only type 1 and type 2. So LSA type 2 and type 1. Only this router 3. Router 3 is internal. Router 3 can send only, how do I know 3? It's ending with 3. I have given IP address like that. 3 is sending to 4. See, it's an unicast. Now, router 3 is sending type 1 LSA, meaning router 3 is forwarding router 1's LSA. Router 3 is forwarding router 1's LSA. Router 1 is here behind router 3. Router 1's advertisement it is forwarding with a sequence number of 2. And it is advertising the metric. You see metric, it's advertising the metric. And also 10.123.02, which is the network behind here. router 1 and router 3 with the metric. It's coming from router 1 and then if you go down, these advertisements are coming from router 3 and these are the networks router 3 originates. Router 3 is directly connected to 34, 10.34, 10.123 and 3.3.3.3. So these are all type 1 LSAs. Let me close this. If you see, type 2 will be coming from designated router. So router 3 is a designated router for router 1. If you want to see, you can go to router 1 and say show IP, OSPF, neighbor. You can see 3333 is the designated router. So router 3's ID you can see because he's a designated router. Only he can send, and he is advertising. He's attached to another router called 11111. So the designated router is attached to its border gateway router. Sorry, it's backup designated router. So these two are actually designated routers. Router 3 is a DR, router 1 is a BDR. You can see that when you go to router 3. Show IP OSPF neighbor. You can see 1111 is a BDR. So it pulls those informations and shows you. The Wireshark can show you all these things. Now let's go to the next one. Now router 4 is sending something more. Let's see what it is sending. Lsa type 1 OSPF header message type update 4. This is not a type for LSA. This is just there's only one LSA type 1 coming here from router 4 as a multicast. As a multicast it is coming and it is carrying these two information. It is just sending as a multicast. But router 3 is not going to learn this. Why? Router 3 already knows about this. Again, same router is sending another advertisement. One is type 4. Type 4 it says, sorry, one is type 1. It says I have these networks. In type 2, it will say these two are, which we already see. Whatever it has learned, from R3, it will propagate again. That's what it is propagating using multicast. So it's going to be the same thing again and again, but I would like to show you the external. I want to show you type 5 LSA. This is network LSA. Okay. This is the special address used to talk to DR. Yeah. So to the DR, it is informing about this network. A BDR, DR other is informing. That will be again propagated as a multicast. But I'm not interested in all this. Okay, this is what. Nice. Look at this. Router 4 is advertising. Router 4 is advertising with his own address saying, I have received type 5 LSA. In type 5 is nothing but autonomous system border router. In type 5 it says, this is the advertising router. Who is this? Who is 8888? It's the ASBR. The router ID of ASBR. That's the place where we redistribute it. And it is advertising about this network 9999 that it has learned. This is the link state ID it has given. And yeah, that's the network it is advertising. But I want more information. There will be more information you see next. You see, the next link first it was learning about 999. Now it is learning about 10.89, which is also from the RIP. Yeah, that is also from the RIP. And you see the default metric is 20. I said when you redistribute, if you do not mention the metric, the default is going to be 20. 20, and it is E2. See, type 2. What is type 2? The metric pathcast will not be added. Listen. For this 99999 from router 1, when I check, I see 20. Go to router 5 and check. There also you will see 20 only for 99999. For 99999, even here it is 20. What does that mean? It means pathcast did not get added. Pathcast is not added. Type 2. And this 20 I did not give while redistributing. It is given by default when you don't mention any metric. OSPF will put 20. So this is our border router ABR, which is advertising the summary LSA. Let's see some more. Type 1 LSA again. Type 5 LSA. See type 5 again coming from our border router. So LSA type 3 and 4 also coming, you see. Sorry, number of LSA is 5. Type 4 LSA will carry the location of ASBR, don't forget. So I should see 8.8.8.8. Look at this. ASBR's router ID is what advertised. To reach that ASBR, the metric is 103. That's OSPF metric. But it's not an external network, no? It's our OSPF router where we do redistribution. Only for the redistributed network, the metric will be 20. There is no need of another filter actually. This is more than enough. It has given all the necessary information that we want. You should try these things. Now what I'm going to do next is I'm going to change E1 to E2 to E1 and show you. Please focus. On R1, when I check show IP route 9.9.9.9, I can see I have learnt it from OSPF. Administrative distance is 110. The metric is 20. The external type E2. This is E2. See, it's the same thing what you saw here. I'm just showing their detail. E2, 110, 20. Go via router 3. It's the same information I'm showing there in detail. Go via router 3. It is originated from router 8. I'm going to change to E1 and I'm going to show you. Please focus. I'm on router 8 now. In router 8, show IP, show run section OSPF. If you see the redistribution that I did not say any metric. This is not the way you should type. Route. And if you see under OSPF, I did not say any metric. No metric I mentioned. I said, hey, just take the rip routes and give. When you say just take the rip route and give, it will give 20, the default metric. And it's the same metric that you saw in router 5. When I type show IP route 9.9.9.9, it is that same 20 here because it is type 2. In router 1 also it is the same 20 because it is type 2. So in router 5 also same metric, in router 1 also same, but there are many links in between, many metrics in between, but nothing is added because it is type 2. I'm going to say no my friend, this redistribution I do not like. I want detailed metric. So what I'm going to say is I'm going to say router OSPF 1 redistribute RIP subnets. I remove the statement. Now if you go, there won't be any redistribution. Go back and check. Gone from the routing table because I removed. It's gone from the routing table. Now I'll not be going to E2 immediately. I want to do one more thing to show you. See, when I say redistribute RIP subnets metric 100. So instead of 20, I'm giving metric as 100. I'm saying the seed metric. What is seed metric? From where the plants grow. From a seed. Likewise, from where the metric will grow. From the seed metric that you give. So I'm redistributing. While redistributing, I'm giving 100. Now I'll go to router 5 and check. It says 100 now, not 20, 100. Means the seed is still a seed, it didn't grow. No one poured water. Go to R1 and check. Again, still the seed, even in R1. So let's pour some water now. What is water? Changing into type 1 metric. Now, metric type is different, metric is different. Metric is 100 and metric type is, you see, you got 2 and 1. What is default? 2 is default. I'm giving 1. Boom. Now when I say type 1, the path cast will be added. So what is that metric that we are expecting? From here to here it is 100. This is 101, 102. Each link is 1, 3, 4, 5, 6. I expect 106 as a metric on router 1. Sorry. Maybe there is some high bandwidth, sorry, low bandwidth link. 205 it shows. 100 is what we gave, but path calculated metric is 205. Somewhere some low bandwidth link is there. It's okay. But increase of metric happens. From 100, we are having 205, which means It's growing somewhere, the metric is 100 for one of the link here somewhere. 100. Now let us try this on router 5. In router 5 it will not be 205. It may be 204 or something. 3 or something. 202. So we can understand that there is change in the metric according to the path metric. The path metric gets added and to the seed metric. To the seed metric, the path metric is added, and we can see the difference only when we change the type 2 external type 1. Earlier when it was 2, the seed was not growing. Did you understand type 1 and type 2?
Yes, sir.
Right. We